So we'll continue the measures of other measures of dispersion in today's session. We discussed about the range standard deviation. So far, using standard deviation, we can compare more than one data set. Within a single data set also, we can compare like how far each value is away from the mean. So in today's session, we'll continue with understanding what is coefficient of variation. This is another measure using which we can understand the spread of the data. What is coefficient of variation? The ratio of the standard deviation to the mean. So we learnt about the standard deviation, we know the mean. If you divide the standard deviation by mean and if you multiply this by 100, you will get the coefficient of variation percentage. The classic example is this one. Look at this table. In this table, we can see that the productivity of each person. These guys, each guys, they are producing some tables. So in 5 days, we have taken the, or instead of person, we can say machines, right? The machines, let's assume that you have 4 machines. Machine 1 fills the Coke can. So we have the Coke can. The Coke can, the machines automatically fills this one and it seals this. Okay, 5 machines, 4 machines are there. So in day 1, this machine filled 18 Coke can. Day 2, second day, this is the thing. Okay, you need to interpret this data like this. And the machine 2 in day 1, it was able to fill only 1 can, and second day it was able to fill 2 can only. Third day, the third machine, it fills more cans. The machine 4, if you see the number of cans filled is very high compared to others. So using standard deviation, we are able to find out the variation. Higher the standard deviation represents what? Higher and lower standard deviation. See, if your standard deviation value is very high, what does it say? If your standard deviation is very low, what does it say? Can someone, let me see how many of you can answer this one. So what does it say? Higher standard deviation, lower standard deviation. Mukhilan, low inconsistency, right? Low inconsistency is what? Higher data spread, more. Okay, Karthik. What about others? Okay, higher standard deviation represents low inconsistency? No. Higher standard deviation not relevant to mean. Gilbert. Higher standard deviation not relevant to mean. No. See, higher the standard deviation. Let's say you are computing the standard deviation for a given data set. Let's say for 18, 19, 20, 21, 22. You have 5 values. If the mean for this one is 20, I need to subtract the mean from each and every value. And then you need to square that, and you add all the squared values, and then you need to divide by 5. That is what the formula for standard deviation. Higher standard deviation represents higher volatility, right? More inconsistency, or higher variability. The spread is very wide. Lower standard deviation, lesser inconsistency, or lesser, it is somewhat consistent, right? So if your value is very less, it is consistent, the data is consistent. In the previous example, we have compared these two data sets. The mean for this data set is 3, the average for this value is also 3. See, all these values, if you take average, you get 3, the average. And if you take the average of all these values, you get mean is 3, average is 3. Both the data set, the average is 3. So does that mean that both the data sets are consistent? Are these two courier companies, they deliver the items on time? Always, so always are they deliver the items on time? Can we say, both the, or if I rephrase it, both these shipping companies, we don't see any SLA violation. SLA violation. That means, they are delivering it on or before 3 days. On or before 3 days. But if you see here, the mean is same. So anyone will tempted to think, so on an average, both these courier companies, they deliver the items on or before 3 days. Good. He is also good. Okay. But only when you find out the variability, right? Using standard deviation, you can see the variability is very high, the variability is very less. Because here, he violated the SLA, right? He delivered, it took more than 3 days, 4 days, 5 days and 6 days. But when you took the average, it was giving 3 only. We cannot go by the average. If you see the standard deviation, with that we are able to find out, or we can spot where the variability is high. Higher the standard deviation requires higher variability. Sometimes they delivered very lesser time, sometimes they took very longer time. Higher variability. Here if you see, most of them are consistent, right? Somewhat closer. We don't see too much of variation. 3, 3, 3, 3, 3, 3. Only one variation is there here. And here only one variation is there. Not much variation. Hence the standard deviation is lesser here. So please remember, see, this is a very basic thing. Higher standard deviation represents higher variability, which means more inconsistency. There is no consistency. Whereas lower standard deviation, look here, in this case the lower standard, the consistency is very high. 3, 3, 3, 3, 3, 3, 3, 3, 3, 3. Most of the time they deliver it on time. Except, two, incident, they, it was varying. Most of the cases we don't see any variation. Hence it is consistent. Higher deviation, low consistency. The lower variation, higher consistency. No. What is Deepak? You are saying higher deviation, lower consistency. No. It is opposite. Higher standard deviation means, correct. Low consistency. Yeah. So low deviation means higher consistency. Very good. So we can say that way also. But in this case, the mean is same, but with the help of the standard deviation only, we are able to find out where the problem is. Which shipping company is causing problem. With this, we can easily find out, hey, this guy is, not delivering it consistently. So there is another situation like the standard deviations are same here. Look here. You take your calculator and compute the standard deviation. Here, the standard deviation is same for all these data set. Then how will you find out the variability? So does this mean all these machines are consistently filling the cans, Coke can? Can we draw? So there are some times we can't even go by standard deviation. Here both the means are same. Hence, just because both the means are same, we cannot draw a conclusion. What we did, we went one step further and we have used standard deviation. With the help of standard deviation, we are able to spot, which shipper is not delivering it consistently. But in this case, standard deviation, if you take it, all the values are same. Yes, right. So higher standard deviation is not closer to the mean, right? So here mean, but the mean is different. The mean is different, but standard deviation is same. The previous case, the mean values are same, but we went one step further and we use standard deviation. With the help of standard deviation, we are able to find out, or spot where the problem is. Now the standard deviation is same, all the data set. Instead of mean, now in this case, all the data sets standard deviation is same. So in that kind of situation, to identify the variability, what we will do is we will take the ratio of the standard deviation to the mean, standard deviation divided by mean. So 1.58 divided by 20, you get this one, you get like this, right? So this is what your coefficient of variation. In this case, what happens is, if you see, look here, higher the CV, higher the coefficient value, right? So lesser consistency. Higher, similar, same thing, higher standard deviation, lesser consistency, right? More inconsistency or lesser consistency. But here, higher coefficient of variation also same as this one, right? More inconsistency. Here 1, 2, 3, 4, 5, not much consistency. Hence, this machine is not filling the cans consistently. Right? This is one scenario. See, like the purpose of this one is, the coefficient of variation is used to compare the consist of two or more groups in the group which differ in their mean. The mean is different, but and also if you want to compare more than two groups, machine 1, machine 2, machine 3, machine, right, different groups, data, if you want to compare it, we can use coefficient of variation. And also the coefficient of variation is very much helpful if you want to compare the different unit of measures of the columns values. You can use this, that we will see at later point in time. Chebyshev's theorem also we discussed, and we have discussed the use cases when we can use the Chebyshev's theorem, how we can use it, we discussed it. Next we will take a look at percentiles. So you must have heard about this term, right? On the GATE exam or some other exam, they might they use this term, percentiles. So what is percentiles? It is most commonly reported. So the most commonly reported percentiles are quartiles, okay, which break the data up into quartiles. Okay. If, let's say somebody says something like this. Let's say your mark is, let's say you scored, let's say your mark is, let's say you scored in an exam 83, okay, 83, and this is your score, and percentile is, your percentile is 50th percentile. So it's something like a rank, okay. So which means 50% of the students, their values fall at or below 83.83. So if somebody says, right, your rank is something like, in your class you scored 90. How many people like you scored 90? Right, so and what is your rank? Your rank is, let's 85th rank, okay, 85th. That means, like your rank is like something like 85th rank or something like that, okay. Or rank, you're not supposed to say rank. It says percentile. 85th percentile means the 80% of the students, they scored at 90. like you know, there are students they scored 90 like you, and also below 90. So that is what 85th percentile says. Okay, so that is what percentile. So the commonly used ones are quartiles. Okay, what is quartiles? In a quarter, it is nothing but quarter. It breaks up the data into 4 quarters. Now let us take a look at this data set. Okay, let us take a look at this data set. See here, I just sorted the data in a descending order. And okay, what is quartile? It's a quarter, right? So we need to divide this data into 4 equal parts. The quartile, something like, see, this is quartile 1 and quartile 2, quartile 3, quartile 4, right? So we divided the entire data into 4 equal parts. The first part is 25th percentile and the median. The second one is 50th percentile. We don't say 50th percentile, instead we say median, and then 75th percentile. We don't say 100th percentile. The 25th percentile can also be referred to as first quartile Q1 or the lower quartile. And the 75th percentile can be referred to as third quartile Q3, or we call this as upper quartile. Okay, so now what we will do is, see now what value is there in 72.5? We need to find out. So it's pretty simple way. I just sorted this data in descending order. How many values are there? 2, 4, 6, 8 and 2, 4, 6, 8. If you want to find out the median, you need to take the two middle values, right? 78 plus 78, this is the median. So what I do is, in between I just draw a line here. Okay, just above this we have 8 values, just below this we have 8 values are there. Median, right? So here what happens, just below this middle value and just above this middle value, once again you need to find out the middle value. So what is the middle value here? So 2, 4, 6, 8 is there. So here you need to, so I'm going to draw a line here. So I divide this 8 by 2, right? So 4 above this line, 4 values below this line. But if you take the median of this one, you just think that way, okay? If you take the middle value for this one, 73 plus 72 divided by 2, how much? 72.5. So this is what my 25th percentile. So this is a data set given. If I ask you to find out the 25th percentile, how will you find out? See, there are some formulas available. The simple technique is you draw the line in the middle, okay, median, find out the median. Not median, find out the median, you draw a line in the middle. Just above this line you have 8 values, just below this you have 8 values. Okay, so okay, now this is a median, this is called your median. Okay, right? So and then what you need to do is, if you want to find out the value for Q1, 25th percent is also called Q1, quartile 1. So what you need to do is, you need to see how many values are there. 8 values are there. So you need to draw a line in the middle, exact middle. So what will happen is, just above this line you have 4 values, just below this you have 4 values. Okay, so in that case you need to add these 2 values. Just below this also you need to find out the median, just above this also you need to find out the median. So for the quartile 1 or the 25th percentile, the 25th percentile value is 72.5. Okay, now you tell me what is Q3 quartile 3 value. Just above this you need to find out the middle value. So 1, 2, 3, 4, 5, 6, 7, 8. I am going to draw a line here, so that just above this line you have 4, just below this you have 4, and you need to add these 2 values. So and divided by 2, 83.5. This is how you need to find out the Q1 value and Q3 value. Q1 is also called as 25th percentile. Q3 is also called as 75th percentile. Okay, fine. So how do you tell this value, so this 72.5, how did we get this? Just beneath this median, again you found the median. So that is what your 72 point, which is nothing but your 25. What does it say? How do you explain this 72.5? So it means that 25% of the data values fall at or below 72.5. See, the 25% of the data that, so there are people, right, they scored 72.5, 25% of the students, they scored 72.5 and less than 72.5. That is what 25th percentile tells us. Now let us look at the 50th percentile. Let me just clean up this. The 50th percentile can also be referred to as median. We normally use the term median. We don't use 50th percentile. When it comes to the 50th, see 25th percentile we say first quarter or 25th percentile. But the 50th percentile we don't use in practice, 50th percentile as it is. Okay, we say median. What is the median here? Can someone tell me quickly? See, that's what I told, right? 25% of the students, listen very carefully. So he has asked a question, Gilbert, what do we infer from Q1 and Q3? That's what his question. If somebody wants to know how many number of students they scored at 72.5 and less than 72.5. 25% of the students they scored at 72.5 and less than 72.5. That is how you can interpret with this one. Similarly, the 50th percent, 70th percent we are going to interpret. So what is the median now? What is the median now? Can you all please type it in the chat window quickly? Yeah. 78, is that correct? 2468, 2468. No, here we have 9, right? 2468. Wait. 2468. Yeah, correct. This is the one, right? The median, the middle one. So you need to, since if you see the total number of samples or 16, hence you need to take the two middle value and divide by 2. Okay, this is wrong here. So here the value is 78. It means 58 that 50% of data values fall at or below 78, which means 50% of the students score falls at 78 or less than 78. We can say that way. Now we have something called box plot. Box plot is a visualization tool or a visual. It helps us to understand how spread out the given data set. In addition, the advantage of box plot is help us also to detect the outliers in your data set. Okay, so now you understood what is Q1 and Q3, what is median. Median is the middle value, Q1 is the 25th percentile, Q3 is the 70th percentile, and minimum maximum value. So these are called your Phi number summary. Please note down Phi number summary. Okay, your project mate, they'll ask you, let's say you are giving a status to your on-site data scientist, right? So you'll ask, can you give me the Phi number summary quickly? So they are asking about this one. What is the minimum value? What is the maximum value? What is the 25th percentile? What is 75th percentile? What is median? Okay, but using box plot, you can plot it like this. Okay, so here, so the box plot is also called as a box and whisker plot. Okay, box and whisker plot. It is something like a cat's whisk, right? On the right side and left side, you can see whisker. So that's the reason why they used to call box and whisker. But in practice, we use this term box plot. In box plot, we can use this, we can plot the Phi number summary. What is minimum, maximum, upper quartile, the median. So the middle one is something like, this one. The median need not to be exactly in the middle, right? It can be something like this. If the value is falling somewhere here for the given data set, when you plot it, let's say customer has given you the data set, you have plotted the data in box plot. What happens is the median falls here. Ideally, the median should be there in the middle. If the median is there in the middle, that means it's a normally distributed. Since the median is located somewhere towards the left side, it's a right skewed data. Okay, it's a right skewed data. We'll discuss that little later. Look here. Now let us understand. We'll work on this problem. Okay. So what is quartile 1 in this data set? This is the one. So what is the median here? Right, what is the median here? Here the median is 22, right? This is the median. Let me do one thing. So here 2, 4, 6, 8, 10, 11. 11 is there. So here it is pretty simple, right? So here on the left side 3 and 6, and the right side 3 and 5. Okay, 5. Okay. 5 and 5. Okay, so if you see here, values are there, right? 11 values are there. So the middle one is the 22. So on the left side, for example, I am comfortable with this 19, this one and this one. If you cancel it, this one and this one, if you cancel it, this one. Yeah, this is the one, 22. This is the median, or we can say 50th percentile. Okay, 22 is the median. So here, if you see here, the 25% of data as a value that is less than or equal to 20. Okay, this is my median, right? So if I draw a line here, what will happen? Just beneath this you have 5 values, just above this you have 5 values. If you find out the median here, this is the one, Q1. See, this is wrong here. The Q1 is 20 here. So what does it say? The 25% of the data, this is my 25%. Okay, my 25% of data as a value that is less than or equal to 20. Next one is, this is my the 50%, 50th percentile. 50% of the data as a value that is less than or equal to 22. Less than or equal to 22. And then if you see here, what is the middle value of these 5? 23. This is what your Q3, which is nothing but your 75th percentile. Which means the 75% of the data. So this is 25 and 25 and 25% up to this. Okay, up to this, and above this you have 25%. So 25%. Up to this you have 25% data, up to this you have 25% data, 25. So that is what your quartiles. And if you add up all these 4 values, you will get 100. You divide the entire data into 4 different quarters, and then if you see here, the 75%, 25 plus 25, 75% of the data that has a value less than or equal to 23. That is what it says. Now if you see this one, 50% of data lies between 20 and 23. Okay, 50% of data lies between 20 and this is my Q1 and Q3. So here you have 25%. You have so we can say this way also. 25%, 50% of the data lies between 20 and 23. So what is the difference between this and this? So here the clause is between. Okay, the 50% of the data lies between. Can you tell me the 50% of the data ranges between which value? Somebody is asking you. So here this 25%, it makes up the middle value. Okay, median. And so the Q1 and Q3, between these two values, right, whatever value is there, so the 50% data lies between 20 and 23, and if somebody is, here there is no between clause, 50% of the data, median, 50% of the data lies, 50% of data value that is less than or equal to 22. That is how you need to interpret this one. I have some example here, okay, some assignment, simple quiz. So now you tell me what is the first quartile here in this data set. So these are like the sales achieved by different sales group in a company. Okay, so now you tell me what is the first quartile. So here we have 3, 6, 7, 8 is there, right? So what is the first quartile here? What is the median here? What is the first quartile here? What is the first quartile? Can someone tell me quickly? Yeah. First quartile is 75, 80. Somebody says 75, somebody says 80. Median is 87.5. 87.5. Yes, the median is 87.5 somewhere here. Okay, this picture is not that good. Okay, actually the median should be 87.5, right? So 85 plus 90, how much? You will get 175. 175 divided by 2. 87.5. Very good, right? So it is 87.5, the median. And what is the first quartile here? What is the first quartile now? 75. 77.5. Karthik says 77.5. So the median is here. Sorry. The median is here. Okay, the median is here. And just beneath this you have, correct, right? So you have 4 values are there. So you need to add these 2 values divided by 2. So you need to add these values divided by 2. So got it? So this is the one. So if you add these 2 values divided by so that is the first quartile. And what was the lowest sales achieved? Somebody is asking you. Let's say the data set is given to you. You plotted the data in a box plot, and you need to give answer to all these things along. See, management, they do not know how to interpret this box plot, because box plot is a technical kind of a technical chart. Only a data scientist or statistician can understand. Okay. Hence, as a data scientist, you need to give all the values along with this visual or chart. First quartile is 77.5. What was the lowest sales achieved? Minimum. This is a minimum value. Okay. What was the highest sales? 105. What was the median sales achieved? 87.5. The middle 50% sales achieved were between which scores? This is my 77.5, right? This is my Q1, and here the 95 plus 100, 195 divided by 2, how much? 97.5. 97.5. So my Q1, this is my Q3, right? Between these 2 values, 50%, the middle 50% sales achieved were between 77.5 to and 97.5. The majority of the sales were above 85. Is this true or false? Let me see how many of you are answering it. Majority of the sales were above 85. Is that true or false? True. True. Yes. Right? Yeah, correct. Top 25% of sales were between which 2 ranges? Top 25% of sales were between which 2 ranges? So this is my maximum value. This is my minimum value. Now we know what is Q1. We know what is Q3. Okay. And what is the top 25%? So this is my Q1, right? This is my Q2, and this is my Q3. This is my the bottom 25%, and here you have 25% data. 25%. You have what is top 25%? This is the top 25%. Top 25% sales were between 97.5 and 105. Got it? This is the top 20. So this is the top, right? This is the bottom, this is the top. So this is how you need to interpret them, and then you need to put this. Correct. You need to put the values. So first quartile 77 point, lowest sales achieved 70, and highest sale you achieved this one. So with this they will be able to. So the lowest sale was 70 and highest sale is 105, and middle 50% were between 77.2 97.5. This one tells you where the data lies in, lies in, right? In which quarter the data value lies in. What is the difference between standard deviation and the percentiles? Standard deviation tells us how far the values are above the mean or below the mean. That's all. But if somebody is asking you, right, can you tell me in which quarter the values are falling, what values are falling in which quarter? If somebody is asking you which values are falling in which quarter, so in that case the quartiles are very much helpful. Percentiles, quartiles are very much helpful. So in this case what happens, for example, you take this one, the middle 50% sales achieved were between here, right? So you can say, so the middle 50% sales were achieved between 77.5 to 97.5. Or if somebody is asking you, or you can tell this one 77. What does it say? 25% of the members or sales team, they achieved the sales at 77.5 or below 77.5. So you can locate where the values are there, in which quartile the values are there. 50% of sales were achieved, 50% of the sales values are 87.5 and less than 87.5, at 87.5 or less than 87.5. Or listen, your score is 87.5, but you are falling in the 50th percentile. That means 50% of students in your class, either their mark is 87.5 or less than 87.5. Now you are able to tell the the range, right? You can tell in which location which values are falling. We can say this way also. For example, 50% of the values, 50% of the let's say 50th percentile. Sorry, 50th percentile. If I say 50th percentile, which means 87 point. So 50% of the students in a classroom, they scored the mark at 87.5 or less than 87.5. That means the rest of the 50% of students whose mark is more than 87.5. You can interpret that way also. When we start using some case studies, you will be able to understand very easily how these quartiles are helpful. That we will see it little later. At this moment, you just keep it in your mind. What is Phi number summary? Minimum, maximum, first quartile, third quartile, median, not mean, median. Okay. So in this data set, can you tell me what is Q1, Q2, 3? Maybe it is wrong. Whatever the line I have drawn, maybe it is wrong. So can someone tell me what is Q1, what is Q2, Q3? Here we have 2, 4, 6, 8, 10 values are there. So yes, I have drawn a line here. You need to add these two values and divide it by 2. Let me see what value am I getting it here. So I did not put the value here, right? So if you add these two values and if you divide these two, you will get your median, which is nothing but your Q2. So now you know what is Q1. Just above this, you need to add these two values, right? You need to add these two values, and then you will get Q1. And just beneath this line 2, 4, 6, right? So that you need to add these two values, divide, that is what your Q3. So add these two values and divide by 2, that is what your Q1. Add these two values and divide by 2, that is what your Q3. The Q2 is in the middle. You need to add these two values and divide by 2. That's how you will get the Q2. So now, this one you can, this is what your Q1, this is what your Q3, and this is what your median. So now we are going to learn one more thing called IQR, Interquartile Range. This is very simple. You need to subtract the Q1 from Q3. If I go back to the box plot, so this is my Q1, this is my Q3. You need to subtract the Q3 value, the Q1 from Q3. So what is my Q3? 97.5 minus what is my Q1? This is 77.5, right? 77.5. If you subtract what value you will get, that is what your IQR, interquartile range. So in the middle, this is in simple term, right? This is what your Q1. Ideally, this line Q1, and this is your Q3, and this is your Q2. Okay, and this is your minimum. This is what your maximum. Okay, let me just clear up everything so that, okay, let me write it neatly. Okay. So ideally, this is what your Q1. Okay, this is what your Q1. So don't literally go by this number. Okay, this number needs to be moved here. Alignment is not correct. And this is what your Q3. This line. Okay, this line is your Q1, Q3. This is what your Q2, and this is what your minimum value. This is what your maximum value. Okay, actually the maximum is 105. And I need to align it. Let me just fix this issue now. So I think I'm using the very older version of this one. So I fixed this in the later version of my PowerPoint, and somehow it is messing up. 105, and then ideally, okay, I'll start with like this. The minimum value is 70 here, just beneath this line. And then somewhere, we need to put it 77.5, right? Okay, something like, I'll just put it like this. What is the median value? How many of you remember? How many of you remember the median value? Here, okay, 105 is missing. 1 second. $87.5 is median, right? So okay, so here I'll just move this a little bit. Here you will get your 87.5. Okay, now this value and this chart matches correctly. This is what your maximum value. 1 second, the maximum value also it's not displaying correctly. $105. So the 105 is your maximum value, and this is your minimum. 70 is your minimum value. 77.5. I just type it here in the interest of you people to understand it clearly. Yeah, 87. So this line, okay. Okay, this is what you. So that is what it says. This is how you need to interpret it. This is how it will plot. Okay, you don't have to manually do it. We have in Python some packages are available. Even in R we have some packages. With that we can. So here you have 25% of the data. Here you have 25% of the data, and 25% of the data, and 25% of the data. So 4 quartiles. Okay, so this is your first quartile, and this is your between Q2 and Q3 you have Q2, and so the IQR tells you the Q3 minus Q1. Q3 minus Q1 interquartile range. This is the interquartile range. Okay, so now so look here. Now you tell me about 50% of data falls within the IQR. Is that correct? About 50% of data. Look at this, image here. About 50% of data falls within the IQR. What is the IQR here? This is the one, right? This is what your IQR. The Q3 minus Q1. So here, about 50% of data falls within the IQR. So you are 25%, 25. Yes, 50% of data falls within the IQR. So now you tell me IQR is affected by every value in the data set. Is that true here? No, right? It is false. Why? Because Q3 and Q1 only are taking into account, right? You are finding out the difference between Q3 and Q1. That is what your IQR. Hence, IQR is not affected by every value. This value is not Q1, Q3, but the other values are not, are not considered here, right? Only Q3. IQR is not affected by outliers. This is what you need to remember. See, in this case, we have an outlier. This value is, unusually, abnormally very high value. So this is an outlier. Just by looking at this itself, we can make out. If I use range, obviously since we have an outlier here, the maximum value is this one, minimum value is this is the one, right? It will tell you the spread is too wide. Even standard deviation also sensitive to outlier. Range is sensitive to outliers. How about standard deviation? Standard deviation is also sensitive to outlier. Okay. So why standard deviation is sensitive to outlier? Can someone tell me? I don't know. Why don't you tell me? Why standard deviation is sensitive to outlier? Range is sensitive to outlier. Standard deviation is sensitive to outlier. Why? Yeah, data spreads more, Karthik. No. Yes, right. So the outlier, in this case, standard deviation is also sensitive to outlier. Range is also sensitive to outlier, which means if I have a bigger value, how do you compute the range? Can all of you please type it? How do you compute the range? What formula that we use it? Which one did I say? I don't know which formula that you use it to find out the range. Maximum minus minimum, right? That is what your range. What is the maximum value? This one. The minimum is this. That is what your range. Standard deviation formula is different. We have discussed, right? But in the case of standard deviation, also it takes into account of each and every value, including the outlier. You need to take the average value. Subtract the average value from each and every value. Even in the case of standard deviation, we are considering each and every value, including the outlier. But whereas in the case of range, yes, we are considering the maximum value. Obviously, the outlier is the maximum value here. You are considering, even in both range and standard deviation, you are considering outlier also. Hence, it is sensitive to outlier. But how about IQR? IQR is resistant to outlier. It is not sensitive to outlier. That is what it says. So even though I have an outlier, we are looking at only one thing. IQR talks about Q3 minus Q1. The difference between Q3 minus Q1 is called your IQR, interquartile range. That is the middle one. Okay, so hence IQR is not sensitive to outlier. That is what you need to remember it. Look at these two values. So you have the variable A has this one and variable B has this value in it. So here we have outlier here. So this is an outlier. So what is the difference between IQR and standard deviation? IQR for both the thing. What is the IQR for both? Can someone, all of you, please type it in the chat window. What is the median value? Very, easily you can find out. This is the median value. And here, okay, here we have 1, 2, 3, 4, 5, 6, 7, right? So yeah, here also it is, we can say, this is the one, right? So here you have 3 values, here you have 3 values, right? So this is your median. Let's say Q2 and Q2. And what is Q1 here? See, just beneath this we have 3 values. This is what your Q1, this is what your Q3, and in this case this is what your Q1, and this is what your Q3. So Q3 minus Q1 is what? Q3 minus Q1 is what? All of you type it in the chat window, so that let me make sure that are you all watching it or not. Okay, very good, Karthik. Karthik typed the value itself, and Q1 is equal to 1, Q3 is equal to 1. Yes, what is IQR here? Mala, very good, right? So what is IQR value here? So here Q3 minus Q1. No, so why do you say Q3 minus Q1 is 9999, Karthik? 3 and 3 values, and this is my okay. Yeah, this is the Q3, right? So Q3, the one is the Q3 and Q1. No, it is not correct, Karthik. IQR is, so Q3 is 1 and Q1 is 1, hence it is 0 here. That's what IQR for both the data set is the same thing. Here also the same thing, right? So Q3 is 1 and Q1 is 1. 1 minus 1 is 0. In both the data set, the IQR is 0. But standard deviation is different. Standard deviation is not same. Okay, which one is really better? Can we go by IQR or can I use only standard deviation? So IQR is very much resistant to outliers. It doesn't consider outliers, whereas the standard deviation is sensitive to outliers. So that is the difference between these two. Now I will give you one simple assignment. Now itself, you all can start do that now. Okay, I'll give something like, let's say, this is the one. I have something called age and number of customers. Okay, so here age is 19 and another guy is 20 and let's say 21, 22 and 23, 24 and 25, and this is the number of customers, right? So number of customers here, I can say, let us say 2, and here I'm going to put 1 1 3 2 1 1. So now you need to find out the, so for age, right? For age you need to find out the Q1, Q2, Q3 and tell me what is the Q1, Q2, 3. Here I have given a table of values. How will you do that? So you need to extract it. So two customers have age of 19 and 20, 21. 3 people have age 22. Okay, and 2 people have age 23. And 1 person has age 24, 1 person has age 25. Now you tell me what is the median for this. All of you type it in the chat window. Let me see how many of you are able to find out Q1, Q2, Q3. Median is 22. Aruna, okay, very good. Okay, and how about others? Mala and Vidya, Vidya, very good. Median is 22. Okay, Sumati is 22. Very good. And Aruna, Q1 is 20. Very good. So how about Q1 is 20? Are you sure? Here we have 3, 6, 9, 10, 11, right? So here 5, and then so after 5, this is the median, and just beneath this you can see this 20 is the Q1 and 23 is the Q1 and Q2 and Q3. What is the IQR? 23 minus 20 equal 3. So this is what your IQR. Okay, now I'm going to explain one more thing with this data set. Look at this one. So you have 19, 19, 20, 21, 22. Now, how do I find out the outlier? What is an outlier? How many of you remember the outlier, the term outlier? I explained to you what is outlier several times, right? What is outlier? Unusually very high value, unusually very small value. So in this data, you tell me, do we have outlier in this data set? Something odd, yes, Sumiti, right? Something very odd, right? So okay. So you don't have outlier. Karthik says there are no outlier. External high or extremely high value or extremely low value. That is also yes or no. And Deepak says no outlier, and Mala says no outlier. Okay. So can we go by your statement? No. This data set also has outlier, but how do we conclude that? How did you conclude we don't have outlier here? Because I told you extremely high value, extremely low value. So does that mean the minimum value is outlier or maximum value is okay? What you are saying is almost all the values are somewhat closer. We don't see very big value with based on your guesswork you are saying it, but we cannot go by guesswork. Okay, so we have a formula for this. Okay, you have something like lower quartile, which is nothing but your Q1 minus 1.5 into your Q3 minus Q1 IQR, which is nothing but your this is see, a potential outlier is any observation that falls beyond 1.5 times, that is any observation less than lower quartile minus 1.5 into upper quartile minus this one. So anything greater than this one, for example, Q3 plus 1.5 into IQR. Instead of saying Q3 minus Q1, you can say IQR, isn't it? So if you want to find out the outlier on the left side, you need to use this one. If you want to find out the outlier on the right side, you need to use this equation. So now you just plug in the value and tell me what is the Q1 value, 20 minus 1.5 into what is the IQR, 3. 3 into 1.5 is how much? 4.5. 20 minus 4.5, how much? 15.5. Okay. So which means any value which is less than 15.5 is considered as an outlier, but in our case obviously we don't have any outlier. Very good. So what you said was correct. So in Q3, what is the value here? 23 plus 1.5 into 3. So 4.5 plus 23, 27.5. Anything above 27.5 or considered as an outlier. This is how you need to find out the outlier. This is the formula that is used. If you want to find out the outlier from the left side of your data, and if you want to find out the outlier on the right side of the data, you need to use this equation. If any value is falling less than 15.5, that is those are called your outlier. Any value which is falling above 27.5 are called your outlier. Fine. So far we discussed about what is percentile and what is quartile, and we discussed about how to plot Phi number summary in a box plot, and how do we interpret the box plot, and what formula that we use it to find out the outliers, okay, on the left side and right side. Fine. So far so good. Next what we will do is 9, 10, 1 hour, right? So okay, we have we'll spend some more time.